Hello guys, and welcome back to this channel. In today's video we are going to solve questions that are likely to appear in the Wassce elective mathematics paper. Here we have a question that is question 1 of Wassce 2020, and this question is on binary operations. Now if you are new here, consider subscribing to this channel. Do well to like this video and share this video to your friends. Now let's get into today's video. Question number 1. A binary operation delta is defined on the set of real numbers R by x operation y equals x plus y plus 10. Now we are asked to find A, the identity element, and then B, the inverse of 3 and negative 5 under the operation delta. So now let's solve the question together. Starting from A, we are going to find the identity element. Now since we don't know the identity element, let E be the identity element. So the letter E is the identity element. Now from the identity element, we know that x operation E is equal to E operation x, and that should give us x. Now what this primarily means is that whenever you combine a value, say x, with the identity element, it is the same as combining the identity element with a value x, and that should give us x. So when you combine x with the identity element, the value does not change, the value still remains as x. Now using this same binary operation, we are going to replace y by e. So wherever we see y in this binary operation, we are going to replace that with e. So x delta e is equal to x plus e plus 10. And then we said that whenever you combine x with the identity element, it should give us x. So the whole of this is equal to x. Now we are going to focus on this. So we say that x plus e plus 10 is equal to x. Now since we want to find the value of e, we want to transpose all the terms to the right hand side. So we leave e on the left hand side, we have x already on the right hand side, and then we transpose x and then 10 to the right hand side. So it becomes x minus 10. X minus x is 0, and then we are left with negative 10. So the value of e, which is the identity element, is equal to negative 10. So the identity element e is equal to negative 10. Now let's solve for b, the inverse of 3 and then negative 5 under the binary operation delta. So to find the inverse of 3 and negative 5 under the operation delta, we need to first of all develop an expression for the inverse. So we say that x operation x inverse is equal to x inverse operation x, and that is equal to the identity element. So when you combine x with its inverse, then we are going to get the identity element. Now we found the identity element to be negative 10. So that's going to help us to find the expression for the inverse. So from this same binary operation, wherever we see y, we are going to substitute that with x inverse. So we say that x operation x inverse is equal to, using the same binary operation, we have x plus x inverse plus 10 equals the identity element, which is negative 10. So we have x plus x inverse plus 10 equals negative 10. So let's transpose x and then 10 to the right hand side. So we have x inverse equals negative 10 minus 10 minus x. And then we can simplify this as negative 1 times 20 plus x. So this is the expression for the inverse. So if you want to find the inverse of 3, then you are going to substitute 3 in place of x into this equation, and then you can find the inverse of 3. And then afterwards, we are going to do same for negative 5. So first of all, let's solve the inverse of 3. So for the inverse of 3, x is equal to 3. So we have x inverse is equal to negative 1 into bracket 20 plus 3. Now 20 plus 3 is 23 times negative 1 is negative 23. So this is the inverse of 3. Now let's solve for the inverse of negative 5. So for the inverse of negative 5, x is equal to negative 5. So that is equal to negative 1 into bracket 20 plus negative 5. So 20 plus negative 5 is 15. Okay, it is 20 minus 5, which is 15. And then 15 times negative 1 is negative 15. So the inverse of negative 5 under the operation delta is equal to negative 15. So that's it for this question. Let's move on to the second question. So for the second question, we are going to evaluate the integral x cubed plus 3 over x squared dx from 2 to 4. So let's solve this question together. So let's rewrite the question. Now to solve this problem, the first thing that we need to do is to split the terms. So we can simplify this as x cubed over x squared plus 3 over x squared dx. So by this, we've been able to split the terms. Now let's simplify this expression. X cubed divided by x squared is x. And then from indices, we can simplify this as 3x exponent negative 2. Now we are going to perform the integration. So in doing so, we are going to increase the exponent of x by 1, and then we divide by the total exponent. So this is what we are going to do. For x, the power of x, or the exponent of x, is 1. So we are going to increase the exponent by 1. So that becomes 1 plus 1. And then we divide by the total exponent, which is 2. And then plus, we have 3x exponent negative 2. So we increase the exponent by 1. And then we divide by the total exponent. Now negative 2 plus 1 is negative 1. So we have negative 1. Now whenever we perform the integration, then the integral sign leaves. So this becomes x squared over 2 plus 3x exponent negative 1 over negative 1. So at this point, we are going to substitute the values of 2 and 4 into this expression. So first of all, we have 4 squared over 2 plus 3 times 4 exponent negative 1 over negative 1. Now because 4 is the upper limit, we substitute 4 into the expression minus, then we can substitute the value of 2 into the expression. So we have this expression minus, now we are going to substitute the value of 2. So we have 2 squared over 2 plus 3 times 2 exponent negative 1 all over negative 1. So now let's simplify this. So 4 squared is 16 divided by 2 is 8. So we have 8 plus, now 3 times 4 exponent negative 1 all over negative 1 is equal to 3 times 1 over 4 all over negative 1 minus 2 squared is 4. 4 divided by 2 is 2. Plus we have 3 times 1 over 2 all over negative 1. So this becomes 8 minus, because of this negative 1, and then 3 times 1 over 4 is 3 over 4. Here we have 2 minus 3 over 2. Now let's find the LCM. The LCM between 1 and 4 is 4. 4 divided by 1 is 4. 4 times 8 is 32. 4 divided by 4 is 1. 1 times 3 is 3. The LCM between 2 and then 1 is 2. 2 divided by 1 is 2. 2 times 2 is 4. 2 divided by 2 is 1. 1 times 3 is 3. So this becomes 32 minus 3 is 29. So we have 29 over 4 minus 4 minus 3 is 1. So we have 1 over 2. The LCM between 4 and 2 is 4. 4 divided by 4 is 1 times 29 is 29. 4 divided by 2 is 2. 2 times 1 is 2. 29 minus 2 is 27. So we say that the integral of x cubed plus 3 over x squared dx from 2 to 4 is equal to 27 over 4, and this is the same as 6 whole number 3 over 4. So now let's solve our third question. Differentiate y equals 3x over 1 plus x squared with respect to x. Differentiate y equals 3x over 1 plus x squared with respect to x. Now to solve this question, we need to use the quotient rule to differentiate y. Now we are going to use the quotient rule because now if y is a function of x and then y is equal to u over v, where both u and then v are functions of x, then dy dx is equal to v times du dx minus u times dv dx divided by v squared. So because this function is in the form of y equals u over v, then we are going to use the quotient rule. Now if we have y equals 3x over 1 plus x squared, then we say that let u be 3x and then let v be 1 plus x squared. So let's find du dx and then dv dx. So du dx means that we are going to find the derivative of u with respect to x. Now we have u to be 3x, so when you differentiate 3x with respect to x, then you have 3. And then for dv dx, we are going to find the derivative of v with respect to x. So this becomes 2x. Now when you differentiate a constant, it goes to 0, so we have 2x. Now you are going to substitute all these 4 values into this expression. So dy dx is equal to, we have v times du dx. v is 1 plus x squared times du dx, which is 3, minus u is 3x, and then dv dx is 2x, all divided by v squared. We have v to be 1 plus x squared, all squared. Now let's simplify. So 3 times 1 is 3, and then we have 3 times x squared, which is 3x squared, minus 3 times 2 is 6, x times x is x squared, divided by 1 plus x squared, all squared. So we have dy dx equals 3 minus, now 3x squared minus 6x squared is negative 3x squared. So minus 3x squared over 1 plus x squared, all squared. We can factor out 3 so that we have 1 minus x squared inside the bracket, divided by 1 plus x squared, all squared. So this is our final answer. We've been able to differentiate y with respect to x. So let's solve question number 4. For question number 4, we are going to find the equation of the circle that passes through the points 2, 3, 4, 2, and then 1, 11. We are going to find the equation of the circle that passes through the points 2, 3, 4, 2, and then 1, 11. Now to find the equation of the circle that passes through all these 3 points, we know that the general equation of a circle is given by x squared plus y squared plus 2gx plus 2fy plus c equals 0. Now since we have the circle passing through 3 points, we are going to substitute the values of x and y for each point into this general equation. And so because we have 3 points, we are going to have 3 equations, and then we are going to solve all these 3 equations simultaneously to find the values of g, f, and c. So let's do that together. So starting from the first point, 2, 3. So we have 2 square plus 3 square plus 2g times 2 plus 2f times 3 plus c equals 0. Now 2 square is 4, and then 3 square is 9. So 4 plus 9 is 13. So this is 13 plus 4g plus 6f plus c equals 0. Now let's transpose 13 to the right hand side. So this becomes 4g plus 6f plus c equals negative 13. Let's call this equation 1. Now to the second point, 4, 2. We are going to have 4 square plus 2 square plus 2 times j times 4 plus 2f times 2 plus c equals 0. So 4 square is 16, 2 square is 4. 16 plus 4 is 20. So 20 plus 8j plus 4f plus c equals 0. So we have 8j plus 4f plus c equals negative 20. Let's call this equation 2. So for the third point, which is 111, we also have 1 square plus 11 square plus 2j times 1 plus 2f times 11 plus c equals 0. 1 square is 1, 11 square is 121. So 121 plus 1 is 122. We have 122 equals 2j plus 22f plus c equals 0. This becomes, sorry, this is supposed to be plus. So we have 2j plus 22f plus c equals negative 122. Let's call this equation 3. So we have 3 equations now. We are going to solve all these 3 equations simultaneously. Now let's multiply equation 1 by 2. So we are going to multiply equation 1 by 2. So we have 2 times 4g plus 6f plus c equals negative 13. So this becomes 8j plus 12f plus 2c equals negative 26. Let's call this equation 4. Now we have 8j for equation 4. We have 8j for equation 2. So we can subtract equation 2 from equation 4. So we say that equation 4 minus equation 2. For equation 4, we have 8j plus 12f plus 2c equals negative 26. So we have this minus equation 2, which is 8j plus 4f plus c equals negative 20. Now 8j minus 8j is 0. 12f minus 4f is 8f. 2c minus c is c. And then negative 26 minus negative 20 is negative 26 plus 20, which is negative 6. Now let's call this equation 5. Now the next thing we are going to do is to multiply equation 3 by 4, so that we solve equation 3 and then equation 2 simultaneously. So multiply equation 3 by 4. So we have 4 times equation 3 is 2j plus 22f, plus c equals negative 122. So this becomes 4 times 2 is 8. So we have 8j plus 4 times 22 is 88. So 88f plus 4c equals 4 times negative 112 is negative 488. So let's call this equation 6. So we are going to solve equation 6 and then equation 2 simultaneously. So we say that equation 6 minus equation 2. So for equation 6, we had 8J plus 88F plus 4C equals negative 488. And then for equation 2, we had the expression, we had 8J plus 4F plus C equals negative 20. So 8J minus 8J goes to 0. We have 88 minus 4, which is 84. So 84F. 4C minus C is 3C. And then negative 488 minus negative 20 is negative 488 plus 20, which is negative 468. So negative 468. Now each of the terms are factors of 3. So we can divide through by 3 so that we have 84 divided by 3 is 28. So 28F plus C equals negative 468 divided by 3 is negative 156. So let's call this equation 7. Now you remember that from equation 5, we had 8F plus C equals negative 6. That was equation 5. Now since we have the coefficient of C for both equations to be the same, we can subtract one equation from the other. So we say that equation 5 minus equation 7. So equation 5 is 8F plus C equals negative 6 minus 28F plus C equals negative 156. Eight minus 28 is negative 20. So we have negative 20F. C minus C equals 0. Negative 6 minus negative 156 is the same as negative 6 plus 156, which is 150. Now because we are going to find the value of F, we divide through by negative 20 so that F is equal to negative 15 over 2. So this is the value of F, negative 15 over 2. Now since we have the value of F, we can substitute F into equation 5. So from equation 5, we are going to have C equals, we are going to transpose 8F to the right hand side. So that is negative 6 minus 8F. Now we have F to be negative 15 over 2. 2 goes into itself once, into 8 4 times. So this becomes negative 6. Negative times negative is positive. 4 times 15 is 60. So negative 6 plus 60 is 54. So the value of C is equal to 54. Now since we know the values of F and then C, we can substitute these values into equation 1 or equation 2 or equation 3, any of the equations which has all the 3 variables, to find the value of J. So from equation 1 was 4J plus 6F plus C equals negative 13. So let's substitute the values of F and then C into this equation. So we have 4J plus 6 times F. F is negative 15 over 2 plus C, that is 54, equals negative 13. 2 goes into itself once, into 6 3 times. 3 times negative 15 is negative 45 plus 54 equals negative 13. Now negative 45 plus 54 is 9. So let's transpose 9 to the right hand side. So we have negative 13 minus 9, and that is equal to negative 22. So we have 4g equals negative 22. Because we want to find the value of g, we divide through by 4, and then we have g equals 2 goes into 4 twice, and then into 22 11 times. So we have negative 11 over 2. So this is the value of g. So we had f to be negative 15 over 2. We had g to be negative 11 over 2. We had c to be 54. So to find the equation of the circle, we are going to substitute all these values into the general equation, which is x squared plus y squared plus 2gx plus 2fy plus c equals 0. So we have x squared plus y squared plus 2 times g. G is negative 11 over 2, x plus 2f. F is negative 15 over 2, y plus c, which is 54, equals 0. So when we simplify, we have x squared plus y squared minus 11x minus 15y plus 54 equals 0. So this is the equation of the circle that passes through the points 2, 3, 4, 2, and then 1, 11. Thanks for watching, and see you in my next video. Bye bye.